and out. So word problems, so read the question, find out what's known and unknown, okay? And then really identify what's being asked. So in terms of maths, with an equation kind of y equals mx plus c times q, some variables basically, figure out what it's actually asking you, what's the variable that it doesn't know, one side of the equation, and all the stuff that you do know. Sometimes you might be given more information than you need to answer the question, because in the world there is almost infinite information, and you have to decide what's the correct or the important stuff you need to know to answer the question. Then basically mathematise it. So convert all of those things, unknowns and knowns, into variables. That you don't have to do that. You could write out the word, kind of Earth's radius or temperature or stuff like that, but it's a lot easier to just put them in to symbols. We'll go through examples of that. And then this is it. This is the hard part. Find the formula. Okay? Or formulae, formulas, however we're going to pronounce that. And once you've done that, then the easy part is then doing the maths. Okay? Just solving that equation. Okay? And then the last part is really important. It's just to look at your answer and think, is that right? And that can either be if you're being asked to do kind of a real world problem and you're asking to solve the radius of the Earth or the age of something, and you come up with an answer that's many, many orders of magnitude, so powers of 10, out from what you think should be the right answer. So if you come up with an age of the Earth of 1 trillion years, then that's probably wrong. If you come up with the age of the Earth as 14 minutes, that's definitely wrong. Okay? But also, sometimes you can use some of this information that you've gathered earlier on to check your answer. Okay, so usually you have a redundant equation which you can use to check your answers. We'll just go through the examples of that. So, these first three examples are relatively trivial. So this is a word type question. Okay, so it's asking you for two consecutive numbers that equal 87. What are the numbers? Okay, so it's like, well, So we'll start out with thinking, well, there are two numbers. Okay, and I'm going to make the first number equal a variable. Okay, I'm going to pick a letter.
X.
X. Well, let's have X. Okay, we'll have X. Okay. Now, I'm not going to give the other number a variable. Oh, let's give the other number a variable. Let's give it a variable. Go on. Anybody else? Y. Really creative bunch, aren't you? You could have had anything. You could have had. Okay, so in the next 5 minutes, I want you to not think about maths, just think of better symbols. Don't do that, think about maths. Okay, X and Y. And we know that Y, one of the variables, because the numbers are consecutive, this one must equal X plus 1. It could be the other way around, but we don't care which one's which yet. This pen is annoying me. We're going to change colour, so a slightly different black. Okay, and we also know that X plus Y equals 87. Okay? So now we've got some equations to do some maths with. Okay? And we've basically one equation and we've got two equations. Now, as a general rule, if you've got two things you don't know, okay, to find out the answers to those, you need at least two equations. Sometimes that's not true. Sometimes you can get away with fewer, but not less. You can, if you've got one equation and another equation that has both of the variables in, you can solve for both of those if you have two equations. And the way we do that in this case is that we've got an equation that's got both of them in. Okay, so and we've got an equation for y, so I can substitute this equation into this one here. So I can make equation 2 become x plus, and I know y is equal to x plus 1, yeah, and that is equal to 87. Okay, so now we've got an equation that doesn't have y in it, it only has x's in it. So if we can solve that, manipulate that and get x, then we're on our way to working out what the other one is. Okay, so in this case we're going to say, well, we can multiply out this bracket. So this is essentially, because there's no number in front of it, it's kind of 1 times that bracket. So x plus 1 times x is x, 1 times 1 is 1, equals 87. Okay? Now that simplifies further. X plus x is 2x. You have campers there. So 2x plus 1 equals 87. I'm going to take away 1 from both sides. Minus 1, which is equal to 86. Okay? And then divide by 2 to both sides. Okay? So that gives us x is equal to 86 divided by 2?
43.
43. Awesome. Super amazing balls. Okay, so now we've got we found one of our numbers. Yeah? So we can now plug that back into this equation here. So now we've got y equals 43 plus 1. Okay? And that is obviously equal to 44. Okay, so now we've got our answer. Now we can check whether it's reasonable, because we've got a redundant equation again. We can just check that x plus y equals 87. So it's 43 plus 44, 87? Yes, it is. Yay! Okay, so we've solved that problem. This one is the same type of thing. So okay, so I'm not going to do that one. I'm going to do this one because this one's harder. Okay, so in this case we've got 7 consecutive numbers equal 7. What are the 7 numbers? Okay, so just thinking about the first one, you might be able to work the first one out without doing any maths. When you think, well, a bit hard. Let's try it out, trial and error. Well, this one's a bit less intuitive. In this case, we're going to have 7 numbers. Okay, first variable. A. Well, we can see where this is going, can't we? Right, first variable is A. Next variable?
W.
B, W, U,
X.
X. Gotta have an X now, haven't you? X.
K.
K. K, and I'm going to have Batman symbol, okay? Just because, why not? Double donkey day to put that in the exam. Don't do that because maths is marking the exam. So A could just be a number we don't know anything about, but because they're consecutive, okay, we can express all of these as equations. So B would be A plus 1. Yeah, C would be A plus 2. Yes, you could have said B plus 1, and then we could have plugged the equation. If we said B plus 1, we could have then plugged in this equation in here, which would be A plus 1 plus 1, and that would also equal A plus 2. Okay? So we'll just carry on with the A's. Plus, 3, well remembered, 4, 5, and 6. Okay? So now we've got we've got 6 equations, so we need a 7th equation if we want to solve for our 7 unknowns. And in this case, it's going to be 7 equals A plus B plus C plus D plus, what is it, Batman, all of those. Yeah? Let's do it properly. Let's use the I got you to use the crazy symbols, so let's use the crazy symbols. 7 is going to be A plus B plus W plus U plus X plus K plus... There's a reason why no one does this. This is the worst Batman symbol ever. Okay, let's just assume that you don't watch Batman movies. Okay, so that's one equation. Okay, so now we've got all of our equations. So all we need to do now is substitute all of these into this. Okay, I'm going to switch colour again. Just red might be slightly more visible. So now we've got 7. Still visible? Yeah, 7. It's going to be A plus 1 plus A plus 2 plus a plus 3 plus a plus 4 plus carrying on, yeah? So that will ultimately simplify to how many a's? 7a, yeah? Plus 21. Okay, so now we can simplify that equation some more. Yes, happy? The easiest way of simplifying that equation? So we can divide by 7, and that gives us 1 equals a plus 3. Yeah? 3 7s in 21. So we rearrange that a little bit more, and that gives us, we've got plus 3 on this side, 1 on that side. If we take 3 from both sides, we end up with minus 2 equals a. So our first number is going to be minus 2. Okay, and that then defines all of our other numbers using these equations. Minus 1, 0, 1, 2, 3, 4. Yep. So we've worked everything out. Now we just need to add them all up just to check that we're getting the right answer. Okay? So noughts and that's something. I think 1 and minus 1, they're going to go away, aren't they? Minus 2 and 2, they're going to go away, aren't they? Leaving us just 3 and 4 equals 7. Happy campers? Cool. So that's the kind of the structure of the process of taking some words, okay, figuring out what maths to do, doing the maths, and then checking. Okay? So a similar example here. Area of the rectangle is 6 meters squared, perimeter is 10 meters. What is the length of its sides? Okay? So in this case, we can say that there are 2 different lengths of sides. So I just... This is the worst one. Okay, so this is an example where it might be good to draw a diagram, but we've got 2 sides, okay? We could call that length A and length B. There's another A and B there, assuming they're rectangles. Okay? So we could come up with an equation for the area. So the area is A times B. And we know that that is equal to 6, because that's in our... we've given that. And then we've got the perimeter. Perimeter is equal to 2a plus 2b. And that's equal to 10. Okay? So we've got the question, we've picked out the information we need to know, we've drawn a diagram, we've got some equations. Okay? So we could simplify this a little bit more to say a plus b equals 5. Okay, just divide through by 2. Equation there. So we can start to solve it. Okay, we could maybe rearrange this equation here to maybe get a equals 5 minus b. Yeah, just move on. And then we've got an equation up here that we've got a times 5 minus b, 5 minus b times b. So I've made this bit here is a. I've just substituted that into this b here. So we've got a, b, and that is equal to 6. Okay? We can go start thinking now about how we might solve that, and hopefully you've realised that because we've got, this is going to be 5b minus b squared. Yeah? So this is going to be a tedious quadratic equation to solve. Okay? Let's see if I can do that on the fly. No, I can't. Not off the top of my head, but we could plug that into the. We could rearrange this to get minus b squared plus 5b minus 6 equals 0. Okay. I guess at this point I could introduce the equation. So we went through before a way of solving these kind of quadratic equations by basically trying to guess what the things are in the brackets. Yeah? And in this case it's going to be quite tricky because we've got a minus at the front here. So any number times any number. So one of these has got to be a b and the other one's going to be a minus b. Okay? And then we've got to think quite carefully about then how we then multiply those things out to get something that's in this one here that we multiply together to get minus 6. Okay, and then add together to get 5b. So that's probably going to be a 2 and a 3. Okay, so let's just think about, let's put a 2 and a 3 in there to start with. That might be the wrong way around. Okay, so if we want this to be positive in the middle, okay, so we've got to do something about this negative here. So this b is going to times by that 3 there. Okay, and that will give, at the moment, it will give, if that was positive, that will give minus 3b, and if this was a positive in here, that would give plus 2b, so that wouldn't equal 5. Okay, if I make that negative, okay, we then have minus b times b, minus b squared. We have minus b times minus 3 plus 3b. We have b times plus 2, that's plus 2b. Okay, and minus 3 times 2 is minus 6. So that works, okay, just by guessing to put them in. Okay, so Massimo will go over a way of solving it for ones that don't work by guessing or thinking about how they plug in, and it will introduce a general formula. But in this case, we know that one of those equals 0. Okay, either that one or that one. Okay, and that's, if we go back to think about our problem, we're going to have two answers. One where this side is A and this is B, and the other one where this is A and this is B. Okay, so this is why there are two answers to this question. So we've got one equation where minus B plus 2 equals 0. Okay, and another one, so you can rearrange that, add B to both sides, that becomes 2 equals B, so B is 2, or we could put the other one where that's one answer, and then the other one is this one where B is minus 3, and that equals B minus 3 equals 0, so add 3 to the side, both sides there. So we've got equation B minus 3 equals 0. Rearrange that by adding 3 to both sides gives us B equals 3. Okay? So we've worked out what B can be. It can be either 2 or 3. And in that case, we can look at our equation, well, any of our equations here. So A equals 5 minus B, or AB equals 6. Okay, we can plug that equation into them, these values for B, to work out what A is. So if we just use this one here, 5 minus B, so A equals 5 minus, A equals 5 minus B, and that equals 5 minus 2, which equals 3, and in this case, A equals 5 minus 2 minus B, where B is 5 minus 3, 2. Okay, so A or B is 2, and A or B is 3. So those are the two numbers. We can then check whether that works from these equations, and it kind of does. Okay. Another kind of more mathematical problem is where you're being asked to show that something is true. Shall I keep moving this away? So in this case, we've basically got one of these kind of tediously annoying maths kind of things, where you can pick any number. Okay, I'd like to pick a number. Anybody? 3. It's a great number. I like it. It's kind of 2 plus 1. It's one of my favourites. So you can pick a number. We can square it. You get. Okay, and then you add 10 times the number. 10 times the number would be 30, so you get then 39. Yeah. Then you add 25, 29 to that, and you get 64. Okay, great, smashing. Take the square root of that. 8. Okay. And then you take away the original answer, which was 3, and you get 5. Okay, and you'll get 5 every time. Any number you pick. Okay? Feel free to go through that in your own time. But the question is asking you to prove why. Okay, so what we can do is we can start to maths it up a little bit. Okay? So we're going to make your number a variable. Okay, and we're going to write out a formula that describes all of that stuff. So let's call your number n, because I can't draw Batman symbol again. Okay? So your number is n, and what we're going to do to it is we're going to square it to get n squared, and then we're going to add 10 times that number, yeah, and then we're going to add 25, okay, yeah, and then the next step is to take all of that and take the square root of it, yeah. And then we're going to take all of that minus n. Okay? So now we have to show that that will always equal 5. Okay? So you can already see that this bit here is kind of starting to look a little bit familiar. Okay, we've got a quadratic equation in here. So we think about one of the things we could do to that is expand the brackets. Okay, and see if some of this stuff starts to go away. Okay, so let's see what we've got. Just ignoring everything else, we're just going to look at n squared plus 10 plus 25. Okay, 10n. Okay, so this should already look kind of familiar to you in the terms of when I talked about the perfect squares. Okay, where the two brackets are the same. Yeah. So in this case, the two brackets, okay, are going to begin with n. Okay. Now the two variables here. Okay. So I think in the slides, those were given m and n as these numbers here. Yeah. Okay. So picking n was not very clever of me. So in future slides, they might be called something else. They might be called g and h or something. It doesn't matter what they're called. Two variables times together give this number, yeah, and then added together will give this number. Okay, what can you guys think what those two numbers are?
5 and 5.
Yeah, so they're going to be 5 and 5. 5 is 25. 2 times 5 is 10. Well done. Put some pluses in there because this is the same and that's a plus. So this equation now starts to look a bit overly complex because we've got the square root of n plus 5 squared. Well, get rid of that, shall we? The square root of a square
It's the same.
is the same. It's the same. And then what do we have over here? We have a minus n. N plus 5 minus n
It's 5.
is 5. Oh, it's so cheap. Well, I'm literally not. Okay, so these are basically what we're trying to do is take these kind of words and then figure out the maths. Okay, so this is a more kind of earth sciences based example. So I've given North Atlantic is getting wider at a rate of something, and currently has a width of. Okay, so the first question is work out the age of the Atlantic, basically. We've got a spreading rate, Okay, and we've got a width. We should be able to get an age. Okay, so in this case, we've got some types of goods. Normal goods and inferior goods. I'm going to have to pick it up. Okay, so we've got BS equals 4 times 10 to the minus 2 meters per year. Okay, and we've got a width W equals 5 times 10 to the 6 meters. Okay, so quite nicely, I've already got the lengths in SI units. We could convert the rate into an SI unit into meters per second if we wanted to, but we'll keep it as it is at the moment. So our answer will be in the units that we started with, so it will be in years. Okay. So what kind of equation are we going to start out with? We've got a rate of something, okay? We can start out with that equation for the rate, right? Okay, so the rate R is equal to the distance divided by time. Okay? Distance over time. Okay? We want to know the time. Okay, quite easily rearrange that guide and get time equals distance over rate. Okay? Then we can plug in we can plug in our numbers. So we know the distance. Distance is W. Okay, so that is equal to 5 times 10 to the 6 over the rate, 4 times 10 to the minus 2. So that becomes quite a straightforward calculation that we can make. Okay, so we've got 10 to the 6 divided by 10 to the 2, sorry, 10 to the minus 2, 5 divided by 4. Okay, 5 divided by 4 is 10 to the 6 divided by 10 to the minus 2. 10 to the 8. Okay, and what's that in millions of years?
Oh God, too many. 25.
What's a million years?
25 million years. Yeah?
Yeah, does that sound about right for the age of the Atlantic?
Maybe, so I don't know.
Well, this is where your kind of like maths knowledge and your kind of geological earth sciences knowledge will have to come in. So the Atlantic started opening in the Cretaceous, maybe a little bit earlier.
No, no.
Yeah, it's fine. So about when the dinosaurs were kicking off or dying. So about 60 million years. So we're about in the right ballpark. We've probably done our maths okay. Okay? And I've only given you the information to one significant figure. So if the correct answer is 60 million years, okay, what's 60 million years, okay, to one significant figure?
60.
Yeah, so it could be, yeah, so the nearest order of magnitude, it's 100 million years. Okay, to one significant figure, it's 60. So we're about right there. So we're using our geology to kind of like get it close. Okay, so that's word equation. So what we're going to do now is think about other techniques about how to fiddle around with equations to find answers to stuff. Okay, so I've said this before, and this is basically the kind of, I guess you'd say, the golden rule. Whatever you do to one side of the equation, you have to do to the other side of the equation. Now, we've been kind of manipulating equations sometimes so we get 0 on one side. So if you do things like divide through by a number, then it doesn't matter because 0 divided by another number is still 0. Okay, but we always have to do what we do to both sides. Find at least one unknown you want to solve. yeah, so we might have to do substituting for individual variables, which doesn't have to be left and right hand side. Yeah. So these are called the solutions if you can find them. So just briefly solving linear equations, simultaneous equations, and quadratic equations. So I think this refers to the, I guess they're both blue books, but the one that was yellow, the one that's not by Paul Palmer. So linear equations are these ones that have this general form, y equals ax plus b, and that we call them linear equations because, I mean, the term linear has two meanings. The meaning that we're going to use is that when you plot it on a graph, you get a straight line. Okay, but it can also, linear equations sometimes are referred to in science as equations where just the result is always predictable. So you can have non-linear equations where you plug in the same value and get a different answer each time, which is a bit crazy, but it happens. So these are just some terminologies. A is called the coefficient, sometimes referred to as the gradient of the graph. There you go, often referred to the gradient. B, x is the variable, it's usually along the horizontal axis, and y is the dependent, and b should be the intercept. Okay, so the value of y when x equals 0. Okay, so if we were to plot, let's go over here. So if I was to plot a graph, okay, where we had y on one axis, x on the other axis, and there was some line on that graph, and that was a straight line. The gradient of this graph would be a, and this value here would be b. Okay. Okay. There's examples of that. So this is where there's just coordinates. So when x and y are both positive, they're over here. When they're both negative, they're down here. It's not so relevant. So to solve an equation like that, imagine we had we didn't know, we just knew that the equation was going to be of that form, y equals ax plus b. But we didn't know what a or x or b was. Okay, we didn't know what the two kind of coefficients were. Okay, so what we would need, if we just had one point that we knew was on the line, okay, you could draw almost an infinite number of straight lines through that point. Okay, so what we would need would be another point. That is useless. I'm going to do orange because I know that one works. There you go, orange. Okay. Once you have 2 points, then there can only be one line that goes through those 2 points. Okay. So if we know what those 2 points are, okay, we should be able to work out what the answer is. Okay. So we can start out by thinking, if we know that this point is say 1 along here and 1 along there, so this point is, we've written 1 dash 1, okay, and this point here, so let's call that 2, and let's say 3 up there. Okay, so this would be 2, 3. Okay, so to work out, and we know that. Let's pick a red. If red works. And we know that the equation is y equals ax plus b. Okay, but we just don't know what a and b are. Okay, but a is the gradient of this line. Okay, so we can work out what that is because we've got 2 points on the line, and we know that this distance here, okay, is going to be 2 minus 1. Okay, it's just the x difference in x between those two values, and this is going to be the difference in y between these two values. Okay, so in this case, it's going to be 2 minus 1 and 3 minus 1. So it's this value, so the vertical and the horizontal. So a is going to be the vertical divided by the horizontal, and that's going to be what do we call it? 3 minus 1 over 2 minus 1, which is equal to 2 over 1, which is 2. Okay? So now we've figured out what one of these numbers is. That's 2x, and we don't know what b is. Okay? But now we've got other points, we know some points on the line. Okay? So we know what the gradient is from this point, and we know where this point is. So we can basically mathematically project that back to the line here. Okay? And we can do that just by rearranging this equation. Okay? So we basically want to know the value of this equation when x is equal to oh no, hang on, no, that's not, that wouldn't help. Well, let's just well, we can, for any one point along the line, we will know y and we will know x. So say at this point here, we know that y is 1 and x is 1. At this point over here, we know that x is 2 and y is 3. So we could say what? We could say y equals 2 times 2. We could say 3, because we know the value of 3, sorry. Because we know at this point here, y is 3 and x is 2. So we just plug 3 and 2 into the equation there. So this gives us 3 equals 2 times 2 minus b, which we don't know. Okay? So we then just rearrange that equation. Okay? We add b to both sides. Okay? So that will be b equals, and divide both sides by 3. Oh, put that. b3. 2 times 2 is 4. Okay? And then we just divide both sides by 3. Go away, so we then get b equals 4/3. Okay, so then that we've now worked out what our equation is. Y equals 2x plus 4/3. Okay, so that's the approach that we use to solve these linear equations. So if you know 2 points on the line, okay, you know their x and their y coordinates. You can use the difference in y and the difference in x to work out the gradient. Okay, it's the vertical distance over the horizontal distance. And then you can plug those numbers back at either of the 2 points, okay, back into the equation for the line to solve for the other variable. Okay, and then you could, if you wanted to, then check the using the other 2 point, the other point coordinates of the other points. If you get the right equation.
So it shouldn't be 1.
Should it? Why should it be 1?
Because when you bring b back to the left side, then you bring 3 over, so it will be 4 minus 2.
Oh yeah, no, that's right. That's correct. I divided both sides by 3 instead of minus 1. Yeah, so plus what is, so this should be 3 plus b equals 4, and then take 3 from both sides. Which is why it's a good idea to check when you do stuff that you get the right answer. Thank you. Good job. So these are the generic equations. So the slope is the difference in y divided by the difference in x. Okay, sometimes difference is referred to as a big delta sign. Okay, and once you've got that, you can then calculate the intercept. Okay, and do that. So you can kind of do it graphically as well to kind of help you think about what those equations mean. So if you've got a gradient that slopes down towards the right-hand side, okay, rather than sloping up, that means that the gradient coefficient, so ax plus b. So if it's sloping down, then this is negative. Yeah? If it's horizontal, it's 0. Okay, and if it's sloping up, that number is going to be positive. Likewise with the intercepts, if the intercept is hitting the y-axis above the origin, it's going to be positive. That's B. It's going to be 0 if it goes through. It's going to be negative if we hit down. Okay, so so these are some examples that you can kind of go through and think about plotting. How are we doing on time? So let's just have a look at what those might look like. So the first one, y equals x plus 3x plus 5. Okay, so we know that one of the points on the line already. If we make this 0 to lots, that's x. This is y, and that will be 0 to lots up here. Okay, we know that if we make x 0, okay, in that equation, y must equal 5. Okay, so one point on the line must be 0, 5. So 0 and then up to 5. So that has to be one point on the line. Okay, and then we just need another point on the line to draw our line through, and we could say draw that at I think 10. Okay, so at 10. Maybe so let's say that that's 10. Okay, so it'll be y would be 3 times 10 plus 5, so that's 35. Yeah, that's 5. Oh, I've done something stupid here, haven't I? 10, 20, 30. We're up here somewhere. So our line would look like that. Okay. We've got another one. Y equals 10 minus 2x. So in this case, when x is 0, y is going to be 10. Yeah. But when it's, let's say x is going to be, let's pick 10 again. Okay, so 2 times 10 is going to be 20. Yeah, but it's going to be 10 minus that 20, so that's going to be minus 10. So it's going to be down here. So that line is going to go down like that. Okay? So you can go through those. I guess we've just gone through how to determine the equations of lines like this. So I think that's probably, well, this kind of thing is useful because sometimes, okay, it's nice once you've figured out what these equations are. So if you have two lines, okay, two equations, it's sometimes physically useful to know when they cross. Okay, so I won't go through the maths of the example, but let's just imagine if we had a come on. Let's imagine that we had a graph of temperature, okay, against depth. Okay, so this is depth into the earth. Okay, we might have it's kind of like it's fairly warm up here, right? So maybe 50 degrees Celsius at the surface. It's like that in Scotland all the time, right? And as you go down into the earth, the temperature increases. Yeah? Now, you might also know something about a mineral, okay, that has a particular relationship between the temperature it melts and the pressure that you're applying to that mineral. So at high pressures, it melts at higher temperatures. Okay? So some rocks are harder to melt when they're under pressure. Okay, so they might have a curve that's something like maybe like this. Okay, where at high depth, where the pressure is high, it takes more temperature to melt it. Okay, and it might not be a straight line, it might be a curvy line, but imagine you could come up with some equation for that. Okay, and you may well do this in next year in geomaterials. But it's kind of nice to know these points on the line there, okay? Because then you can work out what temperature and what depth a particular rock might start melting in the Earth's crust, okay? And the way that we approach this mathematically is that if we know that we've got the two, say these two examples there, let's imagine that those two first equations are in fact the equations for these adiabat and melting curve. Okay, they're not, but let's imagine, in fact, they're these lines here. But it's the same maths, okay? We want to figure out what that point is when they cross. Okay, so we've got two equations, okay, and we want to know the x and y point when they cross. Okay, but we know that x and y must be the same for both lines, otherwise that wouldn't be the point when they cross. So we can just take those two equations and we can make them equal each other, because at that point y for the first equation must equal y for the second equation. So we could say 3x plus 5 equals 10 minus 2x. Okay? So in that case we would say, so y equals 3x plus 5 and y equals 10 minus 2x. We just say that they're equal to each other. So we'd say that 3x plus 5 equals that one. We get rid of the y in the middle. And that allows us to work out x at that point, because we've got, we can maybe minus 5 from both sides. Okay, so it would give us 3x equals 5 minus 2x. Then we could add add 2x, add 2x to both sides, which would give us 5x equals 5, and then 4x equals 1. By both sides by 5. And that gives us 1 point, that gives us this value here, and then we can plug in to either of our equations beginning to work out what that value is when they cross it there. Okay? So that's, I guess, some of the mathematical techniques that you will be using, okay, to solve these linear equations. Okay? So Massimo should be taking over from tomorrow. We'll be moving on how to solve some of the quadratic equations in a kind of a more generic way than the way that we've been doing so far, where we've just been picking the right variables. Okay? So do the top hat stop, start, continue. That'll be useful. There is, I think, a student staff liaison thing coming up soon. Yeah? No, you haven't heard anything at all. Have you heard anything from anybody?
I got one email saying welcome, and it literally said welcome.
From USA or from?
It just said the class represents the team or something.
Okay, that sounds like a USA thing. Okay, so I think there's a meeting next week, which you should be, if not, just fill out that thing or whatnot, and then, yeah, it'd be good to know that.